Alrighty, so in this video, we're going to walk through the model template system and how this system has been expanded for the new moderated mediation models. So in many senses, some of this is new and some of this is old. If you're familiar with using process, this should feel familiar. But if you're not used to using process, then I will walk you through it. So in MEMORE, model 1 is going to be a mediation model. That's been the case since the beginning of MEMORE. In version 2, I added 2 additional models, so model 2 and model 3, and these are moderation models. And the newest version is incorporating models 4 through 18, which are moderated mediation models. And so I'm going to walk through some of these templates, obviously not all 18 of them, but some of the major ones that might be of interest to you, and just explain kind of how the model template system works. So each model is going to have a conceptual diagram and a statistical diagram. And this is particularly important when we're thinking about these repeated measures, mediation models and moderation models, because the way that we estimate these models statistically looks pretty different than when we do that when we're thinking about kind of the theoretical model. So one thing that you might notice, even if you're used to using MEMORE, is that I've changed the way that the conceptual model looks for model 1. And this is because, so previously, if you had looked at this, you would have seen your X variables. So this is our repeated measures factor affecting our mediators. And in model 1, you can have up to 5 pairs of mediators. And so you can have 5 mediators here, pairs being the repeated measurements, and then this X is affecting Y through the mediator variable. The thing that you might notice is new is this little dashed arrow, and this is meant to represent the interaction that MEMORE estimates between the X variable and the M variable in predicting Y. And this is something that is kind of unique to MEMORE and is not something that process does, and so I wanted to kind of emphasize it a little bit more. But also, if you do not want that interaction estimated in your model, you can use the option xmint. And so in all of the models, I have included these dashed arrows as things that can be removed when you turn this xmint option off, so setting it to 0. So the statistical diagram looks pretty different than the conceptual diagram, where in fact what we're doing is we're estimating scores that are the difference score between the pairs of mediators. So if this is our first mediator, this is our kth mediator, and our outcome variable, all of these are difference scores where we've taken the difference between the 2 pairs of repeated measurements, and then we're using an intercept term to just estimate the intercept in some of these models. So you'll notice here the X is not in this diagram because it is represented by this intercept term. And so this is why, in particular, I have both the conceptual diagram so that you can understand kind of what is it that we're doing, but then also the statistical diagram so you understand what is it we're actually estimating. And you'll notice that the mean-centered average of the pairs of mediators are included here in this model predicting Y. And this is where that XM interaction comes in. And so again, you'll see the dashed lines here suggesting that if you turn the XM int option off, then this part of the model will go away. One thing that I'll note here is that all of the statistical diagrams have path coefficient labels such that they match what will come out if you use the save option in MEMORE. So if you save the bootstrap estimates or the Monte Carlo estimates, then you can actually get all of the estimates of these paths across all of the bootstrap samples and then saved with the labels that correspond to what's in the diagram here. So models 2 and 3, when they have one moderator, simplify to the same model. And this is a pretty common model, so I have a kind of separate diagram for this, where we're thinking about the effect of X on Y being moderated by one variable, which we denote W. And in the conceptual diagram, in fact, what we do is we look at the difference between the two repeated measurements of y, and we estimate a regression model with an intercept and a coefficient. And so this coefficient for w, this B1 coefficient, is what is telling us whether or not w is interacting with x in predicting y. Model 2 is actually an additive moderation model, so it allows for up to 5 moderators that are all moderating the effect of x on y, but do not in fact interact with each other. And so in the statistical diagram, we can expand out the previous statistical diagram where we just have multiple w's. And then each of these coefficients is reflecting whether whether a specific moderator is moderating the effect of x on y, controlling for the other moderators. Model 3 allows the moderators to interact with each other, so this is a multiplicative moderation model. And again, the statistical diagram for this gets really complicated because we're allowing for all of the potential interactions between all of the different moderators. And so if you're interested in these moderation models, I have a paper that's in Behavior Research Methods in 2019 that kind of walks through these models, particularly models with multiple moderators, and how to probe interactions in these models. The Model 1 has a serial option where you can then estimate serial mediation models. So conceptually, now one of our mediators can affect another mediator. And so this is an option in Model 1, but it's not an option in any of the other models yet. I hope to, in the future, expand the moderated mediation models to include the serial option, but I had to kind of cut somewhere and give you something. So I decided that was best left on my to-do list. So conceptually, what we do here is we estimate a model very similar to the mediation model, but we also allow for a path between the difference between the first mediator and the second mediator. So here we have a mediator predicting another mediator, and then that allows for a serial indirect effect where we look at the product of A1, F1, and B2. And one thing that I'll note here is that I've changed the notation a little bit, and it doesn't necessarily align with the original paper anymore. And this was to make sure that the save output was a little bit clearer, because we were using kind of a different notation system. So please refer to the templates to understand what the different paths are in the serial mediation model. All right, now probably for what you've all been waiting for, moderated mediation. And one thing that I'll note for those of you who are process users is I've done something a little bit different than process, where process, as the numbers get higher, the models get more complex. In fact, what I've done is model 4 is actually the most complex model. It allows for all of the paths in the mediation to be moderated. And then as the model numbers get higher, we delete certain paths that are moderated, or delete moderation of certain paths. So actually the higher number models tend to be the least complex, and I'll show you some of the ones that seem to be the most popular in process in this memory version. So, but I want to walk through model 4, which allows for all paths in the mediation model to be moderated. So we can see that W is moderating the A paths, so the paths from X to M here. The B paths, so the paths from M to Y here. The direct effect and the interaction, the XM interaction is itself moderated by W. And again, this is something that can be turned off. If you use the XM int equals 0, it will get rid of all of these interactions. But if you just want to not allow these paths to be moderated, there are also models in memory that allow for that. So it's called the D path, and that is then not moderated. So there are some model options for that. So statistically, what's going on here, it's very complicated. I have a paper that has a preprint out that I linked to at the end that kind of walks through the actual logic of why this is the way that we do things, but I just wanted to kind of point out some of the major features. So the base of this is all the mediation model, but then there are some added components. So in particular, we have this W variable now, and we allow it to moderate the A path, which in fact is just the W variable predicting the difference between the mediators. So this is that coefficient allowing that A path to be moderated. And similarly for the direct effect, we allow the direct effect to be moderated by including W as a predictor of the difference between the Y's. So this is the direct effect being moderated. For the B paths and the D paths, we include an interaction term. So here we have the interaction between W and the difference between the mediators. And this path is what is allowing the B path to be moderated. Similarly, we allow for a product term including W and the mean-centered average of the mediators, and this path is what is allowing that D path to be moderated. So essentially what all of the memory moderated mediation models do is every different combination of these paths being moderated or not moderated is available in these models 4 through 18. I wanted to show you a couple of the models that I think are probably most useful or at least most popular in the between subjects literature. So one of these is allowing W to moderate just the A path. So here W is only moderating the path from X to M in these cases, and it's not moderating the direct effect or the B path or the D path. And this is model 15. So this might be a model that is particularly useful. When we look at the conceptual diagram, all that we're adding to this model from the base mediation model is these paths from W to the difference in the mediators, and this allows the A path to be moderated. You would then in the output get things like conditional indirect effects and the index of moderated mediation. Another model that is particularly popular in the between subjects literature is just allowing for the B path to be moderated. So that's model 16, where here W is moderating the path from M to Y. And in the statistical diagram, the way that that is added is by adding this product term between the differences between the mediators and the moderator. And so this path is allowing the B path to be moderated. You'll notice that this does not include moderation of the D path. There is a different model that does this. So if you wanted to incorporate that, all of the different combinations are now available, but only for one moderator. So that's it for the templates. In fact, what you'll get is a PDF that has all of the conceptual and statistical diagrams for all of the models. But I hope that this has given you kind of a general overview about how you might use and think about that model template document and use it for choosing the model that you want to estimate.